Okay, everyone. This is a lab 9, and since last lab, we should have the CBush inserted in all the connections, and regardless about the syntax error, and everything should be fine. And if you are annoyed by that error, you can. There's another way to insert the CBush. So we did that by insert element, create, and 1D CBush. You can also do use this 1D connection, and you can pick one node, then pick another node to create this CBush here. So that way it should not give you the syntax error. All right, but we should have all the CBush we needed, and so this lab we're gonna assign the material properties to the board and also the thickness to the board. And now the first thing we want to do is to assign a coordinate system to the CBush, because this kind of NX doesn't give them a coordinate system by default. So if you go to simulation and you do a model setup check, you will have a lot of warning and errors. So first step, we're gonna assign the coordinate system. So since we're gonna use the absolute coordinate system, and we can assign them at once to every CBush here. So you can pick the first one, then press Shift. While press Shift, you click the last one. So you have selected all this CBushes, but you don't want to select this collector. So now you press Control. Then while press Control, you click on CBush collectors. This one, the collector, this one, and that one. Okay, now all the highlighted items are 1D CBush. So now if you right click on the highlighted items, you can see edit mesh associated date. Okay, we're gonna go inside this, and here enable CSYS override, and you want to make sure this one is clicked. Okay, that's the orientation of your CBush. That means, because remember you signed the 6 degree of freedom, the stiffness. So, but there's no coordinate system right now. So it doesn't know which direction is the DOF1, DOF2. So now we're gonna check this and make sure it's absolute. So that way we're gonna use this absolute coordinate system. Then we can click OK. Alright, so next step, we're going to define the material for the skateboard, and let's start with the bushing. So we go to 3D collectors, and if you like, you can hide all the other stuff, but we're going to just right click on the solid collector here, Then you go to edit, okay, and here you click this monkey wrench again. Then this one, material. So if you haven't defined anything, it should be none or inherited. Now we can go inside this icon, click this icon to choose the material, and this is all the material I have built. Let me show you how to build from the start. So we can delete them, and library. So by default you should go into this category at first. So what we did is we pick a material first. It's plastic, it's close to the bushing, so it might have some thermal property in this material, and we don't need that, but we want to pick a similar material to the material we're going to use for the bushing. So you can do a copy selected material and wait. So now you just copy this material, and we're gonna modify this material to let's say rubber for the bushing. Okay, and so we don't need to care about the mass density. All we need to adjust is the Young's modulus and the Poisson ratio. So for the rubber, for bushing, we're gonna use 1.45 e to the 5 psi. So be careful about the unit here. Let's go to psi, this one, and make sure your input is under the right unit, e to the 5. Okay, and the Poisson ratio for the rubber should be 0.45. Then click OK. Now we have one material made here, and excuse me, we can go ahead and create all the material here in this one step. Okay, and but you can also click OK and assign this material first, and then create later. I'm just gonna create again. So you click copy over there, back there, and then we're gonna rename first. Now for the wheels and the truck, also the connector, we're gonna use Ultem. It's a hard plastic, so we're gonna name that Ultem wheel and truck. I believe that also said Ultem wheel truck and assembly. So also we don't care about the mass density, and the Young's modulus is gonna be 4.0 e to the 6. The Poisson ratio gonna be 0.3, and then we click OK. Now there are two material here, and we're gonna add the material for the board. You can pick either one and click copy the selected material, and rename this as wood for the board. Okay, then the Young's modulus is going to be 1.5 e to the 6, and also the Poisson's ratio going to be 0.3. Then we click OK. So for the X, we don't need to create a new material because an X already have steel inside. So we are done here. Just click OK. And for this, we were defining the material for bush, for the bushing. So we're gonna pick rubber. See, if you have created a material, they'll be here. Okay, you can pick rubber for bush and click OK. Then click OK again. Alright, so we have done with the bushing. You can hide it. That way you know you have defined the material for the bushing. Then we can go ahead and define the material for the wheel and the truck and the connector. So I'm wondering if we can define them all together. Well, apparently it's not. And now we're gonna define them one by one. So you right click on the wheel on the collector level, then click edit. Here you click the monkey wrench again, edit. Then since we have created the material, we can pick from this menu. That will be Ultem. Okay. Then click OK. OK. Alright, we're done with the wheel. We can do the truck and click edit. Edit again. Select the material from the menu. That'll be Ultem. OK. OK. Next is the connector. Click right click, edit, edit, then Ultem. OK. So we're done with the 3D collectors. And we can go here, 2D collector, define the material for the board. Again, you click right click on the collector and click edit and edit. Alright, here is 2D 2D mesh, so you have a little bit different stuff here. We need to use this thickness. So the thickness is gonna be 1/4 inch. I'm gonna input 0.25 inch. Make sure the unit is right. Then the material, you can pick a lot of material here, but we're gonna only use material 1. That's gonna be the wood for the board. Okay. Then you click OK. OK again. Alright, we have done the definition of the material for the board. The last thing is the shaft or the axles. So let's see if this collector has all the shaft. Okay. So if you have 2 collectors for the shaft, you'll need to define them one after another. Okay. Then right click, edit here, then edit and material. We're gonna choose from the library. So look, I click on this item, choose material icon, sorry. And this is local materials. You want to pick from the library, the built-in material. And we are going to use steel, rolled steel. This one, rolled steel. Click OK. And see here, it's called steel rolled. Click OK. Then OK. Alright, we have assigned all the material for this skateboard. So we are done in the fan side. And also you have to remember to assign the orientation or the coordination system for the CBush. Okay. And if everything looks okay, then you can do a save all. Let's just have it. Then we can go to simulation. So here in simulation, we're gonna define the load and the constraints. All right, enter. Now, speaking of constraint, we need to give this wheel some point to grab, to simulation the drag from the ground to the wheel. So we still need to go back to the fan and create some spiders on the bottom, so you can simulate that the fact that the wheel, when the wheel touches the ground, it's not a point touch or a very small. Instead, that's a small area touch, if you imagine that. So we're gonna pick the let's have a look here. So we're gonna pick this 3 rows of nodes to simulate that the ground touching this 3 row of nodes. So that way, and that's when we need spiders here. So we can actually grab the center of the spider, then further grab this small area of nodes. So again, for spiders, first we're gonna create a center node, and for the center node, we want the node to be in the center of this line. Okay, so we're gonna go insert node, create, and here you can do a point dialog, because we're gonna insert a point between 2 points. Okay, then we choose between 2 points. So specify point 1. Let's see which one are the bottommost nodes. Okay, that should be this 2. Then first one, the second one, and that's the center is gonna be the node we are creating. And click OK. Then we can do apply. That is one node. Then we go into create for the other the other 3 wheels. Okay. Then between 2 points, then point 1, point 2. Okay. Apply. And goes to the rear. Where is the okay, here. So that will be this place, and point dialog between 2 points, point 1, that's point 2. Okay, apply. And then here again between 2 points, point 1, point 2. Okay, then the last one we click OK. Alright, so you have 4 points on the center of the wheel touching the ground. And we're gonna go insert the spiders. So make sure the element type is RBE2. Okay, the source node gonna be the center node. Okay, then the target is going to be this small surface. It's gonna be 1, 2, 3, 4. So we have 12 nodes here, and you want the filter to be at no master. Then we can pick the nodes. Alright, I'm going to just put this 1, to that doesn't look right. Yeah, that's inside. And for deselect, press Shift and click on that if you're lucky. Try to use this. Too bad. Cancel. Alright, do that again. Source, target. 1, 2, 3, 4. Okay. Next row. Okay, you have 12, and yeah, the element type should be RBE2. And you can do, we need a new collector for these spiders. And okay, everything's good. Source, target, element type, and a new collector. Click OK. Here you go. And here, this we're gonna rename this to touch, and we can make it look nice. Maybe black. Okay. So this is one, and I'm gonna skip the tedious process to create these spiders. I'll come back later. Okay, now we have 4 spiders, and you want to turn on the wireframe and rotate. That way you can see if the spider is actually created properly without being any nodes inside the wheel. So if you accidentally pick up the nodes inside the wheel, you will see some spider legs goes into the wheel. And now we are ready for the simulation. So if you do a save all, just in case, and we can go to the same. Alright, so now we're gonna define some constraints and loads. So first we're gonna fix the wheel to the ground, and we're gonna go here, constraint type, and we are using user defined constraint. Click this one, and select object. Either we select this, yeah. So we select the center of the spiders. This way, if you grab the center of this spider, it will grab this small face of the wheel. So we're gonna select 1, and too much stuff here. I can actually turn off this. Select 2, and that's another spider from the wheel. And here, that's a 4th. Okay, 1, 2, 3, 4, and we want to fix all 3 direction of translation. So we're gonna fix DOF 1, 2, and 3, and leave the rotation free. Let's say OK. Alright. So let me turn back on the mesh. So if you feel they look too small, you can come here and let's see where's the constraint. User define 1. That's for the wheel. Right click, edit display. Now we can go like here, scale, large, apply. See that? Okay. Now if you remember from the class, we also need to grab a node on the board to prevent this, the rectangular effect. So if you look at here, this is one, it's like a 3-bar structure. If you look, this is 1 bar, that's another bar, the whole piece on the top is the 3rd bar. So this is actually not a stable structure, that's why it will roll. So if you don't grab this one, you only grab this two and the bottom nodes, so it's like you have a hinge here, a hinge here. The top bar will move left and right. So for this simulation, we need to grab the center node here to prevent this from happening. Okay, now you go to insert a user-defined constraint, and we're gonna eliminate the x direction translation for this node. Okay, so click this node, and we're gonna fix DOF1. That's the x direction translation. Just click OK. So now we have all the constraints. Let me make this bigger. Okay. So with 4 wheels, we fixed the 3 degree of translation, and for the center, the orange node, we fixed the x direction translation. So you're gonna be careful about those fixed or not fixed degree of freedom. Next step, we're gonna apply the load on the board. So we want to turn off 1D and 3D collectors. No, that's only the board. Then we go to insert the load type. That's gonna be pressure. Okay, so the direction, we're gonna be careful of the direction. It's gonna the positive z direction goes up. So the pressure we want to go on the negative z direction. So that's gonna be negative, and the number gonna be 3 pounds for a uniform pressure. But I think Dr. Zada has done that on the class, and for uniform it's pretty easy. You just select the whole board, then you click OK. This will give you a uniform 3-pound pressure. If you times the area, that's about 300 pounds. That's a pretty big guy. And alright, so I'm not gonna do this, but you will need to do this in the report or the homework. So that's the way you apply a pressure to the board. And for the simulation, I'm gonna do half and half. It's like when you ride the skateboard, you lean to one side, so the right and left will have bigger pressure than the other side. So you can delete this and insert 2 different pressures, and I'm gonna just add it. That is the first one. Now let's go to F8. I don't like this view. We should go this view. Okay. Now if you notice this 964 nodes here, or elements, so I'm gonna put 3.5 pound on one side, and then you can reselect. Okay, I'm gonna press shift while you select. That's gonna deselect half of the board. Okay, so now we put 3.5 psi on the right side of the board. Now we can click OK. Try apply. Alright, click OK. So we have applied it to the right side. Then we're gonna apply pressure to the left side and move this a little bit. You box select only the top or the left elements. Okay, you make sure it's only half of them, or you can look at the number of the objects. It's gonna be 482, or whatever you have on your board, divide by 2. So this side of it's gonna be lighter, so we put 2.5. Then you want the average value of this two sides be the same as the pressure you put on your uniform load. So that way we can compare the reaction force, the total reaction force, and they should be the same. Let's click OK here. Now you should have two pressure. And if you remember, the right side should have 3.5 pounds. The direction is going to be negative Z. So remember to put the negative sign before the pressure. Alright, so we have the constraint and we have the pressure. We have constraint and the loads. Okay, we're gonna go do the solution here, and you want to do a model check first, model setup check. And if you have a lot of errors, you can have a look and find out which part of your model is, has something missing or whatever. And let's go do solve here. Before that, I'm gonna save all. Then you go solve. Also, you want the reaction force to be printed into the file. So we go edit solution attributes and select a case control output request, and you're gonna click this edit wrench. So here we are going to SPC forces, and the output median for this, the default gonna be plot. So we want to modify this to print. So this way you will have the values input in your F06 file. Then we click OK. And OK again. Then we can click OK and solve the problem. Finger crossing. Then wait. And that's here. Job finished. Close. Cancel. Close. And hopefully there's a result here. Displacement. Alright, so if you look at the results, should be able to see this. It goes to the heavier side. So remember we put 3.5 to the left, to the right side of the board, and the left side is of 2.5 psi. And if you look at this direction, you can totally see the trend. Okay. Also, I don't know if we can. Okay. Let's go this way. F8. If you can see this, the axles are actually turned to the right a little bit. So I know you all can play skateboard. If you press to the right side, then it will turn right. So that's pretty much match the reality. Okay, so you can compare the numbers to your model and to mine, and this is all the simulation part. And thank you very much. Hope you can get a good result.